Hello everyone, welcome back to Concept Brunch with Riddhi. It's a beautiful November evening and I have got my cup of hot coffee with me, perfect for getting started with today's topic. Hope you all are settled and ready because today we are beginning the theory of trigonometric identities. What to expect in this class? In this session, we'll explore the basic of trigonometric identities, understand their significance, and solve a few introductory questions to build your confidence. You may recall that an equation is called an identity when it is true for all values of the variables involved. Similarly, an equation involving trigonometric ratios of an angle is called a trigonometric identity. If it is true for all values of the angle involved. In this section, we will prove that one trigonometric identity and use it further to prove other useful trigonometric identities. In this triangle ABC, right angled at B. Okay, so you apply the Pythagoras theorem, so we can write AB square plus BC square equal to AC square. Okay, divide each terms by AC square. So AB square divide with AC square plus BC square divide with AC square equal to AC square divide with AC square. So let us approach the angle A. So according to that, this is your opposite, this is your adjacent, and this is your hypotenuse, correct? So AB we can understand as the adjacent square divide with hypotenuse square, plus we can understand this as opposite square divide with hypotenuse square, and that is AC square by AC square is 1. Adjacent divide with hypotenuse we can write as a cos square A, plus we can write this as a sine square A, and 1 square is 1. So just write it in a correct way. So sine square A plus cos square A equals 1. This is our first identity. This is true for all A such that A should be greater than or equal to 0 degree and less than or equal to 90 degree. This triangle in a different way we can approach it. That is your what? AB square plus BC square, that is equal to AC square. This is what? Using the Pythagoras theorem in a triangle ABC. Okay. This time I'm not dividing with AC, I'm dividing with AB square, both sides. So let's divide with AB square. Okay. So this is obviously this is going to be 1. BC, that is opposite, and the AB is what? Adjacent square, opposite square, sorry, is equal to AC, that is your hypotenuse square, divide with AB, that is your adjacent square, right? So if you recall my previous video, I have told all the values. So from here, 1 plus opposite square divided with adjacent square we can write as a tan square A, because we are assigning the angle A, and this side hypotenuse divided with adjacent we can write as a secant square A. Okay, let's write in a sequence. So we can write secant square A minus tan square A is equal 1. You can remember like this also, anything is fine. Is this equation true for A equal to 0? Yes, it is. What about A equal 90 degree? Well, tan A and secant A are not defined at 90 degree. So this is true for A when it is between 0 degree and less than 90 degree. Okay, let's approaching to the third one. Okay, again apply the Pythagoras theorem here. So we can write AB square plus BC square equal to AC square. This time I'm dividing with BC square. Okay, everywhere is fine, right? AB we can write as a adjacent square divide with BC is opposite square, plus BC as opposite square divide with opposite square, which we can cancel and we can write as a 1, and AC we can write as a hypotenuse square divide with BC we can write as a opposite square. Okay, adjacent divide with opposite, that we can write as a cot square A, plus 1 equal cosecant square A. we can remember like this, or we can approach like this as well. Cosecant squared A minus cot squared A equal 1. Note that cosecant A and cot A are not defined with A equal 0. It's not defined here, right? Therefore, it's true for the angle between 0 degree and less than or equal to 90 degree. Have you ever wondered why we write sine square A, not sine A whole square or sine A square? It's just a shorthand to make things easier. Sine squared A is simply means the square of the sine A. Writing in this way keep the things neat and avoid confusion. So we know the squares applies to the sine value, not with the angles. Okay, so this format we use for other functions like cos squared A, tan squared A, and so on. Even mathematicians have used this notation for centuries and it has become a standard. It is compact, easy to use, and widely accepted in all branches of mathematics. Let's recall all the formulas. Okay, so this is a triangle ABC, right angled at B, and let's consider angle A. Okay, so opposite will be this one, that BC. This will be adjacent, and AC is going to be hypotenuse, right? So from here we can write as a sine A equals opposite divided with hypotenuse, right? Cos A we can write as a adjacent divided with hypotenuse. Tan A we can write as a opposite divided with adjacent. Just opposite of this we can write as a cosecant A, that is 1 over sine A, or we can write as a hypotenuse divided with opposite. Similarly, secant A we can write 1 over cos A, which is hypotenuse divided with adjacent, and cot A, that is equal to 1 over tan A, which is equal to adjacent divided with opposite. Even let's do one more formulas to derive here. Tan A equal what? Opposite divided with adjacent, right? Let's divide up and down with hypotenuse. Okay, now opposite divided with hypotenuse is sine A, and adjacent divided with hypotenuse with cos A. So for the tan A we can write the two formulas. What is that? 1 over cot A and sine A divided with cos A. Okay, along with the three trigonometric identities, that is your sine squared A plus cos squared A equals 1, secant squared A minus tan squared A equals 1, cosecant squared A minus cot squared A equals 1. So these are the all formulas we are going to use to solve the questions for trigonometric identities. Okay, let's get started. First question, in the LHS part, left hand side, and this is your right hand side part, right? So first we will take the LHS part and we will prove equal to the RHS part. Okay, so let's start. Over here what is given to us? Secant A 1 minus sine A times secant A plus tan A, right? Now what we will do, convert everything, the secant, tan and secant, in the sine cos. Okay, so on the place of the secant A we can write as a cos A 1 minus sine A, secant A we can write 1 by cos A plus sine A divided with cos A. Okay, so 1 over cos A 1 minus sine A, take an LCM, so this will be cos A and 1 plus sine A. Okay, so now 1 minus sine A, 1 plus sine A, right? We can use the one of the different formula, that is A minus B times A plus B. If you remember, I already talked about this in my previous video, you can check out it. So we can write A squared minus of B squared. So here we can write 1 squared minus sine squared A divided with cos squared A. We just use one identity, that 1 equal to sine squared A plus cos squared A, right? So for cos squared A we can write as 1 minus sine squared A. So here 1 minus sine squared A we can write as a cos square a divided with cos square a, and which is equal to 1 equal to RHS, hence proved. This is our second question. In this question, this is your LHS and this is the RHS. Let's take the LHS and proves equal to the RHS. So here cot A minus cos A divide with cot A plus cos A. This is given the LHS. What I'm going to do, I'm going to convert everything into sine and cos. Okay, so cot A, what we can write? We can write as a cos A divided with sine A minus cos A. Cot A again we can write as a cos A divided with sine A plus of cos A. Okay, here what we can do, we can take cos A as a common. What is remaining? 1 over sine A minus 1, and here cos A again common. What it's remaining? 1 over sine A plus 1. We can cancel out the cos A. What is the remaining here? 1 over sine A minus 1 divided with 1 over sine A plus 1. So 1 over sine A we can write as a cosecant A minus 1 divided with cosecant A plus 1. And this is your RHS, hence proved. Hey friends, I just want to share a quick piece of advice with you. When it comes to trigonometric functions or identities, remembering the formulas is super important, but it's only half of the battle. The real magic happens when you apply them. And to get really good at it, you need to practice it a lot. It's like learning a new skill. The more you work on it, the easier it gets and the clearance the concept become. So don't rush, keep practicing, and soon these formula will start to feel like second nature. You have got this. Let's keep going strong together. I will discuss more questions in next video. Keep learning, keep practicing. Stay tuned. Goodbye. See you in next video.